For today's reteaching lesson, we're going to kind of combine 7-2 and 7-3. So the learning objective for 7-2 is to estimate quotients when dividing with decimals, and then 7-3 is the goal is to use number sense and estimation to determine where to place the decimal point when dividing with decimals. So these kind of go hand in hand, so we're going to talk about them together. When estimating with decimals, we're still going to use the same strategies that we've been using all year of either using compatible numbers or rounding to make the problem easier. Remember, when you're finding an estimate, you should be making the problem so easy that you can do it mentally. So to me, compatible numbers works the best in division. That way you can get an even answer with no remainders or no decimals left over, just get a flat answer. So to me, compatible numbers makes more sense when using decimals. And just a reminder, I like to throw this in there every now and then in case we forget. Compatible numbers are numbers that are easier to add, subtract, divide, and multiply mentally. So here we have the problem 47 3600 divided by 5 9500. And we're wanting to find an estimate for this problem. As I said before, I think that using compatible numbers when dividing makes the most sense because then I don't have to write out the whole problem and do long division. I can just do a simple multiplication fact that I can do mentally. So looking at this problem, I noticed that 5 9500 is really, really close to 6. So I'm going to go ahead and round that up to 6. And then I want to think about, when looking at 47 3600, I want to think about multiples of 6 that are close to that number. So, I could start listing them out, but I could also see that these are kind of far away and go ahead and jump down. I know 6 times 6 is 36. Then there's 42, and then there's 48. And I see that 48 is pretty close to this number. So I'm going to go ahead and change 47 3600 to 48. And notice that this isn't following a rounding rule, because if I were to round this number, I would round it down to 47. So here I'm using compatible numbers to find a quick estimate. So 48 divided by 6 is a times table simple fact, mathematical fact that you probably have memorized. And 48 divided by 6 equals 8. So my estimate here is going to be 8. And you could use rounding if you wanted to, in which case you would get 47 divided by 6 if you're rounding to the nearest whole number. But then you would really have to write it out and do the long division and figure out what your remainder was or turn it into a decimal. And I just think that using compatible numbers is a lot easier. It's not as time consuming. Alright, so this is where lesson 7-3 kind of comes in. This is where we're going to use our estimation skills and our number sense, our number understanding, to figure out where we should place our decimal. So let's take a look at that first problem up there. 103 9500 divided by 6 9300. So what we're going to do here is go ahead and either find compatible numbers or go ahead and round these numbers to help us find an estimate. So I'm going to go ahead and take 103 9500 and I'm going to change that to 100. And then I'm going to divide it. And if you were to round this number, you would round it to the nearest whole number. You would round 6 9300 up to 7. But I don't know 100 divided by 7 off the top of my head. So I'm going to go ahead and change 6 9300 to 5. Because I know that 100 is a multiple of 5, and it's going to be something that's going to be really easy to divide mentally. So when I do this problem, my quotient is 20. So now, based on my estimate of 20, I need to figure out in this quotient up here, which just has the correct digits, it's still missing its decimal point, where my decimal point belongs in that quotient. And so if I were to test out each of these options, I could figure out where it's going to go. So if I were to put it behind the 0, I would have 150, and that's quite a bit bigger than our estimate of 20. So I'm going to keep on trying other options. If I put it between the 5 and the 0, I'd get 15. And that's pretty close, and I could probably assume that that's the correct answer, but I could also think, well, what if I put it between the 1 and the 5? If I were to do that, is it going to be close? Not really. It's going to get us down to 1 5/10, and that's quite a bit smaller. So we're going to go ahead and put our decimal point between the 5 and the 0, and our final answer here is going to be 15. Lovely decimal point there, don't you think? All right, next problem. I want you to take notice of the fact that this problem has a dividend, the 4 725 thousandths, that is smaller than the divisor. Our divisor of 15 is larger than our dividend, and that really kind of goes against everything you're kind of used to seeing with division. So here I'm going to go ahead and do what I would normally do. In this case, I'm going to round. Well, you could use compatible numbers as well. The 5 kind of is, but it's kind of funky because usually you're used to saying 15 divided by 5. So I want you to think about if you had 5 apples and you wanted to give some apple to 15 people. Well, you wouldn't be able to give a whole apple to anybody because you don't have enough. So in this case, we know that our number, our quotient, is going to be less than 1. Think about if you cut that apple up into pieces, and so you had enough pieces to give it to 15 people. So anywhere that we put our decimal besides right out in front is going to give us a whole number. If we were to put it behind the 3, that would give us a whole number of 3. If we put it between the 1 and the 5, that would give us 31. And then if we put it behind the 5, that would get us 315. Well, we're taking a number and dividing it by a larger number. So our answer has got to be less than 1. So we are going to put our decimal before that 3. Okay, so think back to the apples. If you had 5 apples and you wanted to give it to 15 people, you'd have to cut it up in 315 thousandths of a slice so everybody could get some of that apple. All right, let's take a look at the next one. This one's going to be, I think, fairly easy. It's very similar to the first one. I'm going to go ahead and use compatible numbers here as well. So I'm going to change my 12.4, and I'm going to change it to 12. And then I'm going to divide that by 4. And again, I have compatible numbers here because 12 is a multiple of 4, so I can quickly divide and see that my estimate is going to be 3. Based on that estimate, I can go up to these digits up here, the 302, and I can figure out that I need to put my decimal point right after the 3 because that's going to be the number that's closest to my estimate. All right, we're almost done. Last problem. We have 63 divided by 52 hundredths. And this one's another kind of tricky one. This one's kind of like this problem up here. The difference is that my last problem here follows the rule of the divisor being smaller than the dividend. However, this divisor is less than 1, and that's not something that we're really used to working with. So let's take a look at what these would be if we were using compatible numbers. So if I were to use compatible numbers here, I would change 63 to 60, and I would divide that by 1/2 or 5/10, okay? So now let's think about if I had one whole, how many halves are in each, or in that whole? So I have 1/2 here and 2 halves here. So in one whole, I have 2 halves. Seems kind of confusing. So I need to figure out in 60 wholes, how many halves do I have? So let's think about if we were to draw another whole circle. Well, here I have 2 halves. So if you want to think of it like one whole equals 2 halves, I don't have enough room. 2 wholes equals 4 halves. You can kind of see our pattern. We're taking our whole number and we're multiplying it by 2 to figure out how many halves are in that whole. So here we have 2 wholes. Think of these two whole circles down here. And we have 4 halves. So we have 1, 2, 3, 4. So we're going to do the same thing with our 60. When we're figuring out how many halves, because we're thinking of equal groupings here, we're going to do the 60 times 2 to figure out, to kind of follow this pattern and figure out how many halves would be in one whole. So if I do 6 times 2, that's going to get me 12, and then I add my 0 onto the end, I get 120. So we're going to have about 120 halves in each of the 63 wholes. I know it's a really confusing concept because this number has just gotten bigger. So when we go to look at our final problem, we're going to actually put our decimal point between the two ones. We have approximately 120 halves in 63 wholes. So this is the most logical place for our decimal point. And this kind of goes against what you know about division as well, where you've always learned that when you do division, your number gets smaller. The trick with that is that when your divisor is less than 1, it's actually going to get bigger. Because like this lovely picture I drew over to the right, you're thinking about the halves. You're not thinking about the wholes. How many equal groups of half do I have in this number? So in 63 halves, we're going to have 63 wholes, we're going to have 121 and 15 hundredths halves.